Okay, so another carbonyl containing functional group that we're going to learn about is a ketone. So remember, the carbonyls are C double bond O's. So all the C double bond O's, that's the carbonyl. The next functional group is a carbonyl sandwiched between two carbons. So that is called a ketone. And an example of a ketone that you probably are exposed to often would be acetone, nail polish remover. So that's to be used on the natural nails, not the acrylic. Well, that's a different functional group that's used to remove nail polish on the acrylic nails. What's that?
I didn't know
Acetate.
that.
Yeah. So ethyl acetate is an ester, and we'll go over that functional group coming up. That you use to remove your nail polish if you have acrylic nails. It doesn't remove the nail polish as well. So if you have natural nails and you want to remove the nail polish without as much rubbing, then you can use the acetone, which is a ketone.
I buy the non-acetone.
Yeah, I know.
It takes forever.
Yeah. Yeah, now you know. So, you know. Okay, the ending for ketones is the O-N-E. And common name, alkyl ketone. Let's see. Example I have. The thing about ketones, they are always in the middle of molecules because they need to be sandwiched between those two carbons. So they're always in the middle. The IUPAC, final longest continuous chain of carbons, that contains the carbonyl, the C double bond O, and that ketone. And that will be your parent. So in this case, it's 5. So it would be pentane, but you take off the E and you add the O and E. So it's going to be pentanone. So pentanone. And then you need to tell me the number where the carbonyl is. So it's on the second carbon.
Because it could be on the 3.
Right. Could be 2 or 3. So for the common name, you cover up the actual carbonyl. Yeah. So then you name what's on the left and the right. So you have 3 carbons on the left and you have 1 carbon on the right. So that's going to be propyl and methyl. You'll list them in alphabetical order, so it would be methyl propyl ketone.
Oh, we did it on the back.
I know, sometimes it takes. But it's good that you're looking out for it. Alright, so that's ketone. The next functional group that contains a carbonyl, C double bond O, OH. So it looks like a carbonyl and an alcohol together. So this is called a carboxylic acid. So you know you hear about the skincare names, all this. This contains alpha hydroxy acids. This is better for your skin. So it's a carboxylic acid, and we'll learn about this, and it contains an OH one away from the carboxylic acid. but we'll get into that a little bit later. The ending for IUPAC is oic acid. The common name, like your aldehydes, you can only have 3. Formic acid, acetic acid, or benzoic acid. So if you're limited, formic acid is 1 carbon. 2 carbons is acetic acid. And if you're thinking acetic acid sounds familiar, that's vinegar. So, and then benzoic acid is here. Acetic acid is vinegar. That's right. Usually, most vinegar is like a 5% acetic acid solution. Benzoic acid is an aromatic acid with a carboxylic acid. So it's a benzene ring with a C double bond OH coming off. The example I have. So, like always, IUPAC, find the longest continuous chain of carbons, add oic acid, drop the E, add oic acid to the end. So this is 4 carbons, and your parent is going to include that C double bond O in it. That's important. So it's kind of like the double bond. Those carbonyls are really important to include in your parent. So this would be butane, but it's butanoic, and then a space acid.
Is that one always on the end too?
Yes, always on the end. Thank you. These colors look so crazy on the screen. On my computer, they look. I can see that they're colors, but then on the screen they look looking different. So for butanoic acid, there wouldn't be a common name that we know of. There's a common name that exists, but we only teach you a few common names, the ones that you most often see. So, all right, the next functional group. This is an ester. So you can have carbons here. And then, so it's like a carbonyl married to an ether. So this is an ester. And as a rule, esters smell pretty sweet. So thinking about your nail polish removers, acetone doesn't smell very good, but ethyl acetate, which is used for acrylic nails, smells kind of sweeter, more pleasant, fruitier. So we have a lab where we make esters and you smell them. So,
Like your skin product, Ester C. Is that?
Huh.
No.
ester C, and what is it used for?
I think like vitamin C.
Uh-huh.
It's just
Maybe it's. Let me see. That's it. Ester C. I'll write that down. A lot of times to get molecules across the cell membrane so you can absorb them, they have to have carbons to make them, so
Okay.
you can't, so it's kind of a strategy in getting them to permeate, your skin, your cells. So I'll check into that for you.
That's a carbon that does that?
Yes, carbons, yeah. Because you have this lipid bilayer that, it's polar, but it's also non-polar, and there's a whole strategy in trying to get molecules across that bilayer. Yeah, and so you can't have them, at a certain molecular rate they won't pass through, but if you have molecules that are extremely polar, they won't pass through either. So it may be that there's some ester involved to make it more likely to permeate that cell membrane. Okay, the ending for esters is O-A-T-E. And my students a long time ago, they were good friends, and they took this class together, and they were always trying to encourage each other, you know, with little mnemonics and everything. But the way they remembered esters, Aunt Esther always eats oats, something like that, so that they remembered the O-A-T-E ending. So common names, again, you're restricted because you have form, a set, and then your benzene one. So it's formate, acetate, and you see acetate a lot, you know, ethyl acetate with your nail polish removers. Benzoate. A lot of times you'll see these used as preservatives, like benzoate. You might see in different bread products. They extend the shelf life a lot, so it's an ester. Now the example that I have, I think esters, amides, and ethers are one of the hardest functional groups to name. They're just a lot of parts to keep track of. So this your parent contains the carbonyl and the oxygen. So this is 1, 2, 3. That's propane. Take off the E, add O8. This is for your IUPAC name. Propanoate. And then this methyl group that's hanging off your oxygen, that needs to be named as well. That's methyl. So methylpropanoate. So it's 2 words separated by space. No hyphens or anything are necessary. Methylpropanoate. And then, because this parent contains 3 carbons, there isn't a common name that we name. There is a common name out there, but we don't get into it. Okay, so then the last functional group looks like a ketone has married an amine. So it's a ketone glued to an amine. And this can it can have hydrogens here or carbons. So the functional group name, amide, amide, tomato, tomato. The ending, amide for IUPAC. Again, you're restricted with your common names, formamide, acetamide, benzamide. So hopefully some of these names from your orange flashcards are starting to jump out at you. They're not, oh, okay. So the more you see them, the easier they will become. All right, so here is the example molecule that I have. The longest continuous chain of carbons that bears the C double bond O in the end is 1, 2, 3. So this is propanamide. So propane plus amide. Propanamide. And then over here I have a methyl group coming off, but it's not coming off an oxygen. It's not coming off the carbon chain. It's coming off the nitrogen. So you use the N-methyl, like we did with the amines. And that one just kind of runs together, N-methylpropanamide. So I'm hoping, like spending some time going through this, that, we have gone over what we're going to cover in Unit 4. Just a very quick preview. We're going to go into it in more detail, and there's some solubility things and some reactions that we'll cover. But this is the nomenclature part of it. So the functional groups that I want to warn you about, the ones that are challenging: esters, amides, and ethers tend to give students the most trouble. So if you find yourself banging your head against a wall and saying, I just can't get ethers, I just can't get esters, I just can't get amides, that is completely normal. When I was a student learning organic chemistry, probably the most challenging functional group for me was esters. And I just had to keep practicing them. And you'll find that too. And this unit in particular, when I was a student, I would make photocopies of molecules over and over again. And just, so if you have a few pages from your pink book, make photocopies or print out practice problems online, and then just do them over and over again until you get them all correct. So, all right, on the next page, this is for you to fill out, make copies of, and that's for you here, guys. On page 3, I have molecules. And these, I don't want you to immediately freak out and say, oh my gosh, we have to name these. You don't have to name these. All I want you to do is to circle the functional groups in these molecules. Now some of these molecules, it's the line angle. So this is, it's like a skeletal structure. This stands for carbon, 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 carbon. Okay, so in this first molecule, does anybody know what this is?
It looks like, is that one of the pairings of DNA? One of the.
Yeah, it is in DNA in the purine, but I think this is caffeine.
It's a benzene
Oh.
with
Yeah.
That's what's in here.
Yeah,
naphthalene,
no, it's close. This is a
pentane with a
purine. Yeah, so you see it in DNA, but it's caffeine.
benzene. Really?
Yeah. So everybody needs some at this point, right? And so, but in terms of the functional groups in this molecule, I want to, work with these, or work with you on these. So when you have a carbonyl, circle it, highlight it, look to the left and the right of it. If there's anything that's non-carbon to the left and the right of it, that makes a difference. So like this, carbonyl with the nitrogen, what functional group is that?
Amine.
Good. So amide, there you go. And then you have the same thing here. A lot of times what students will do with amides, so I'm telling you what not to do. They'll circle this one and they'll say, oh, that's an amine, and this one is a ketone. So I encourage you to look to the left and the right of your carbonyls. If you have anything that's not a carbon, then that will influence what your functional group is. So these two, they're just nitrogens connected to carbons. These are both amine. Questions on that one? Experiment 13, which we'll be doing next time in lab, is all over functional groups. So it goes over the 9 functional groups. And then on the back page of experiment 13, there are molecules. You're not asked to name them, but you're just asked to circle and label the functional groups, just like we're doing tonight. So this is good practice for experiment 13. All right, what functional groups are in this molecule? Amine, Okay, so this, very good. This molecule, what functional groups do I have? Alcohol.
No. The carbonyl acid.
Right, so when you see that carbonyl, highlight it, circle it, go to the left and to the right. So because you have that OH coming off of here, that's a carboxylic acid.
Some of the use in skin views.
They do use acids, yes. My mom once got one that turned her face blue.
That's fun.
I think she was all excited about how it was going to be, you know, rejuvenating, you know, look youthful. But it was about the same time that my husband and I got engaged, and so they hosted an engagement party for us, and she had a blue face. I mean, it was blue. She looked like a Smurf. But and she couldn't peel it off. She had to wait for it to peel off naturally. So, but yeah.
What'd she have done? Or
Just to peel.
My mom had a glycolic peel or something, and it burned her face. She had chemical burns on her face forever. She was so upset.
Yeah, you have to be careful with those. She have any suffering skin damage?
It looks fine now, but I mean, for a while it was very dark. It looked like almost like some kind of skin condition. She just had these really dark patches on her cheeks, and then it was peeling, and she was in an awful mood. Had some kind of bug up her butt about it. Now she's okay.
I can imagine it's, you know, unpleasant. You're promised one thing, and then it doesn't work with whatever your skin. I mean, I think it's good to be aware that not everybody reacts the same way to things. What about this functional group here? It looks a little different. It's a nitrogen, and it's connected to a carbon.
Oh, it's the one with the form.
Amine, yeah. So,
Oh, so it's the same.
So amines, you know how some people say, you know, they have a lot of different looks? Amines have a lot of different looks. So look different with just hydrogens or all carbons. But if it's just a nitrogen with no carbonyl neighboring it, then it's just an amine. All right, so I want you to work on the next few molecules. You're not naming, you're just trying to identify and label functional groups. These structures at the top, this first one on the left, I told you, is caffeine. This one on the right is nicotine. Okay, so for the functional groups and the ones that we're still working on, what's this one? Amine, good. And then this one is a ketone. Good. This one is ether, good. And this one, alcohol. This one is Ester. Ketone. And then what about that one? Ester. Good. So any questions on how to identify functional groups? Work on experiment 13 now. You know, after class, you can practice these.
what chemicals were those?
I don't think these are any that or an important note. I wanted to make sure. I knew this one was caffeine, but I wanted to make sure that was nicotine, which it is. So, if you're real interested, the next time we meet, I'll bring you some structures of like heroin and morphine, because you can see these drugs are like they're similar. Some just have an OH, some might have an ether, and it makes it easier to pass through that membrane. So it's pretty neat to see that. Okay, so now we're going to be getting into spending more time on learning how to name each one of these functional groups in addition to other things, like, you know. So, alcohol, what's a functional group in an alcohol? OH, yes. So that is the functional group in an alcohol. Just like we learned how to classify carbons, primary, secondary, and tertiary, we're going to do the same thing with alcohols. This will really help you for reactions of alcohols. So we will have a lot of reactions in Unit 4 as well. So just like before, primary, secondary, tertiary. So a tertiary alcohol looks like this. The carbon to which the OH is bonded to has 3 bonds that are non-hydrogen, say something like this. So that's tertiary. So you're looking at the carbon here. That carbon has 3 non-hydrogen bonds. That makes it tertiary. So for secondary, you have your COH bond. You're going to have 2 non-hydrogen bonds in addition to the OH, and then you're going to have 1 hydrogen. And that's secondary. So this one. So this is secondary alcohol. This is tertiary alcohol. A primary alcohol, carbon bonded to the OH. The OH is bonded to 1 carbon and then 2 hydrogens. So that carbon is primary. So like I said, we could ask you to identify primary, secondary, or tertiary alcohols, but you will use this a lot more with reactions. So it's kind of a helpful way to write, well, eventually we'll get to this point. Primary and secondary alcohols can be oxidized, but tertiary alcohols can't. So you'll start to use it, just to write out little, things to remind yourself about reactions. So when you're asked to classify alcohols as primary, secondary, or tertiary, the only place you're looking is the carbon that bears the OH. That's the only place you're looking. So this first one, what would it be? Primary. Good. So primary. Is that right?
No.
It's tempting. Tertiary. So I'm glad I'm getting an array of responses. primary, secondary, or tertiary. With these geometric formulas, it is very easy to make mistakes on classifying alcohols. So be careful. Look at the carbon bearing the OH. How many non-carbon bonds is it? 2. So it makes it a secondary. So hopefully by making that mistake now, you'll be less likely to make that mistake on the quiz. Maybe it will jump out. Oh, I got to remember. All right, what about this primary? There's your primary. Excellent. What about this guy? Secondary. What about this last one? Tertiary. Yep. Tertiary. And hey, I'm just going to name these for you so that you get exposed to these. We're going to learn how to name in just a second for alcohols. So this would be cyclobutane, but it has an alcohol. So it's cyclobutanol. Cyclobutanol. That's the IUPAC name. We won't have a common for that one. IUPAC for this one would be ethanol. Now putting a number on that one, you don't have to because there are only 2 carbons. The OH is going to be on the first. You're always going to set that as the first carbon. Common name, cover up the OH. What alkyl group is that? Ethane, but it would be ethyl. Ethyl alcohol. Note that it's not. I'm trying to think of how students can. Ethanol alcohol. Sometimes students will merge the IUPAC and the common. So it's not that. Okay, this next structure, IUPAC, longest continuous chain of carbons that bears the OH, would be 3. So it would be propane, propanol, and 2 propanol. Common, cover up the OH. What alkyl group is that? Not sec-butyl. Isopropyl alcohol. This last one can only be named by IUPAC. Cyclopropane, cyclopropanol, 1-methyl cyclopropanol. And I don't have to say the 1-cyclopropanol. It's kind of like cyclopropene. The double bond is always between carbons 1 and 2. The OH is always numbered 1 in cycloalkanol.
So if it wouldn't have been nitrogenous,
The methyl would be 2. Mm-hmm.
So was the last unit just to kind of like ease into this, but it's not the way you named? Or is it just like different structures that's named?
We go about there's simpler structures in Unit 3.
Okay.
They're just a lot simpler.
So it's when you have these groups, like the OH is connected in a certain way.
Right. So it gets more complicated. So yeah, I do think it's a good thing because you're still learning. It's so much of a language component in this unit, on both units 3 and 4. So I have the rules explicitly stated. Again, like from what we have in the table on page 63 in your pink book, or page 1 of your note packet, Unit 4 note packet. So with IUPAC, the rules, number, and this, it's not a hashtag.
You're so bad.
I know, hashtag, yeah. Surprised I know that, but, so I have that as the number to know, to let you know, in 95% of the cases, you will need to put a number. The exception was ethanol, because it only had 2 carbons. Methanol would be another one, because that just has 1 carbon. So, you know, if you're debating whether to put a number or not, put the number, you'll get a half point deducted if it doesn't need to be that type of thing. But I'm not real picky in this unit if you put a number and it's redundant, you know, like, there's a lot to keep track of. So, I don't fret too much about that. What would the IUPAC name be for this structure? So it's butane. So butane. Take off the E, add the OL, and then the number. Where's the number for your alcohol? So 2. So it's 2-butanol. Common nomenclature. Cover up the OH and name the alkyl group. This is the alkyl group from Unit 3. So if you're a little rusty on your Unit 3 alkyl groups, your isopropyl, isobutyl, sec-butyl, T-butyl, go back and study those. You know, put those flashcards into your rotation. So sec-butyl. Sec-butyl alcohol. All right, what do you think? Remember in Unit 3 we had diene. That was 2 double bonds. A diol is 2 alcohols. Yes, 2 alcohols. So it's the nomenclature for diols. Hashtag. Alkane. Plus diol. So number, alkane, diol. You need to put 2 numbers because you have 2 alcohols and they could be on the same carbon, they could be on adjacent carbons, they could be on totally separate carbons. But just like double bonds, when you have 2 of them, you need to put the numbers, even if they're in a ring. So I have structures here, and I have lines if they can have IUPAC or common names. So if they have a line for both IUPAC and common, then they can be named both ways. On the exam, I would accept either. Some of them only have 1 line for IUPAC. That means they can't be named with common. So let me go over more. Let's go over this lower left one. What's the longest continuous chain of carbons that the OH is off of? You guys can read this. It just looks intimidating. So 7. So it would be heptane, but I have heptanol. Excellent. All right. Which way would I number it? Left to right or right to left? Left to right. Good. So 1, 2, 3, 4, 5, 6, 7. So it would be, what's coming off the second carbon?
Phenol.
Yes. That's very good. 2 phenol. 1 heptanol. That's the IUPAC. That's 2 phenyl, 1 heptanol. There is no common for that one. I want to distinguish since we just talked about phenyl, this is phenyl. I always think of phenyl, F-E-N-N-E-L, vegetable. So phenyl is this, when you have a benzene ring that's hanging off of a chain of more than 6 carbons. You learned, or you were in the process of learning this one. Does anybody know what that's called? Phenol. Phenol. So be careful when you're writing out your names that you don't put OL or YL. That makes a big difference. Just one letter means a different chemical compound. So I believe phenol is in like chloroseptic throat spray. If you have a sore throat, it helps relieve your pain. So we'll break here. Well, once you can start working on the rest of these names, but we'll talk about them when we come back.